Okay, so let's start with the general expression for change of entropy of a perfect gas. Okay, in this derivation, we're going to prove the in terms of pressure and volume. We prove the general relation of change in entropy in terms of pressure and volume. Either they ask in terms of pressure and absolute temperature, either they ask in terms of volume and absolute temperature. Also, they ask in such a manner that they show that the specific entropy change for a perfect gas in a process is given. Like that, they ask prove that the change in entropy in terms of temperature volume, either in terms of pressure volume or either in terms of temperature and pressure. Okay, so the first, if we see the in terms of volume and absolute temperature, okay, then let's start with the first law of thermodynamics or the general gas equation. We know that what amount of heat we supply for the system, okay, they utilize for the two purposes. First, there is the change in internal energy and work done. Okay, if we see the change in internal energy and work done, we know that work done is nothing but pressure into change in volume. Okay, after if we see the internal energy, in the first topic we also discussed the internal energy for the different processes, and the general formula for the change in internal energy is mcv delta t, and the work done is the pressure into change in volume. So this is the first general, or either we see this is the first law of thermodynamics. We apply the general formulas, change in internal energy and work done. After that, if we see here, dividing by t on both side. Okay, after dividing this t both side, we get dq by t mcv dt by t plus p into dv by t. Starts with the first law of thermodynamics. We put the general formulas of internal energy and work done. After that, it is divided by t on both side. But we also know that the pv is equal to mrt. Okay, and if you see here, what is the need to put this formula? If we see, okay, for getting the complete equation, okay, I'm going to take the integral, okay, in further steps. But if we see that reciprocal or the denominator of that dv by is the t, so it is necessary to change. So I use here pv is equal to mrt, okay, and the replace of that p by t we put here mr by v. So that equation 1 becomes that p by t is replaced by mr by v. We know that general gas equation pv is equal to mrt. And we know that the Clausius equation, that Clausius inequality proves that that term dq by t we call as that term is the change in entropy. So dq by t is entropy, and the main target is to form the general equation for entropy. So that purpose I purposefully divided by t on both sides. So this term is change in entropy. Okay, mcv delta t by t mr dv by v. Okay, now we can easily take the integrating equation within appropriate limits. Okay, the process is carrying on initial state 1. After addition of it, the process or the state of the substance is state 2, maybe at proper appropriate limits. Okay, so the change in entropy S1 to S2, mcv is a constant. Okay, in integral dt by t, m is a constant, r is a constant as characteristics gas constant in terms of v2. Okay, after simplifying the integral equation, we can prove that the s2 minus s1 mcv. Okay, we know that the integral of dt by t or 1 of t, the log to the base e t2 upon t1 plus mr is constant. We take the integral of dv by v is the log to the base e v2 by v1. So if we see, this is the first proof that the general gas equation in terms of temperature and volume.